So now we will see not equal to operator. Let's understand the concept of relational operator with not equal to operator now. It will return true if the corresponding element of the first operand, which is list 1, is not equal to the second operand, which is list 2. So if we check element by element, true is not equal to 0. True is not equal to 0, which is correct. True is 1 and 0 is 0. So the output would be 0. 0.1 is not equal to 0, which is again false because 0.1 is equal to 0. So here again the output would be 0.1 is not equal to 0. The output would be false because it is equal to. Apple is not equal to bat, which is true. Apple is not equal to, so output would be true. Next we have the assignment operator. Let's see what is an assignment operator. Assignment operator, as we all know, it is used to assign a value to a variable in R. The objects can be integer, vectors or functions. These values are then stored by the assigned variable names. So there are two kinds of assignment operators, left and right. So you can see over here, there is left assignment which assigns a value to a vector, and there is a right assignment which again assigns a value to a vector. So it is totally up to you which assignment operator you want to use, because from country to country the typing styles are different, and in certain countries we use the equal to sign, and in certain countries we use the left arrow and the minus sign, because the flow charting decides your operator, because in certain countries the flow charting is done showing the arrow, and in certain countries we go with the equal to sign. So basically assignment operator is very easy. Here in this example you can see BEC1 is a variable vector 1 and it is assigned a value AB and true. So you can see C is my function where I am passing AB and true, and the values I am storing in vector 1, and then I am printing vector 1. So now when I print vector 1, what is my output? Very simple. My output is AB and true. So you can say true is also my output and AB is also my output. So these are my two values which are coming on the screen as an output. Let's have a look of code which illustrates the usage of all relational operators along with assignment operators. So here you will see the code where there is vector 1 which is assigned a list from 2 to 5. You can see if I'm writing C and within brackets I write 2:5, it means the range of values from 2 to 5. Likewise, I can also write C 2:5 is equal to vector 2. So vector 2 is also 2:5. That is also one more way of storing a value into a variable. Third one is vector 3, which is again 2:5. So you can see the output in parallel, that outcome is 2 to 5, but there are so many ways to store this. Vector 4 equals to 2:5. This is the fourth line, vector 4 variable is the line which is very much popular in C, and we normally go with this operator in India. C 2:5 is assigned vector 5. So here we have just stored the value in the vectors, and then the commands are simple, which is cat command, which is as good as a printf command, the printf command we have, or the cout command we have in C++, or printf command we have in the C language. Likewise, we have the cat command in R. So vector 1 is vector 1, vector 2 is vector 2, and that is how we have printed. And you can see there are 4 new lines, so that every time after printing we come to the next line, and then we are printing what? 2, 3, 4, 5. Next we have the colon operator. So we have seen in the previous example the colon operator that we were assigning the value from the lower limit to the upper limit and storing that into the variable. Like we had stored the value from 2 to 5 with the help of C function into a variable C1, vector 1. So now suppose I want to directly print values from 1 to 5. So there is a very good operator which is called as colon operator. And colon operator is mainly used to print values from the lower limit to the upper limit. So here you can say print 1:5 and the output is 1, 2, 3, 4, 5. So prints a sequence of numbers from 1 to 5. You can see over here that from 1 to 5, we have printed the numbers very easily by just passing the to range. So this is such a powerful colon operator we have. If I want to print a series of, let's say, from 1 to 500, I just write 1 to 500 and press enter, and you see everything is coming on the screen. Likewise, we have a percent in percent operator. Now this is my favorite operator because this tells us whether first is present in the second or not. So it checks if an element belongs to a list. The idea is if an element belongs to the list and returns a Boolean value true. So if the value is present, it returns a true, and if the value is not present, it will return a false. So let's understand with example. The value is what? The value is 0.1. Now I'm searching 0.1 in list 1. I want to find out whether 0.1 is present in list 1 or not. So what will I do? I will write list 1 is true, 0.1 and apple. So I have created val, which is a variable, the value to be searched, or I can say search value. List 1 is my first list of values, and print command, where what I'm doing, val in list 1. So it is checking values present in list 1. If true, then it prints true. And if it was not present, the output would have been false. So mainly this is a search operator which will search a particular value in a list of values. Next, we have the functions. So basically the idea of function is that I create it once and I reuse it again and again. So the idea of reuse, and that is why reusability increases the programming speed and reduces the number of codes. And definitely when the number of the program is smaller, it is termed as energy efficient also, because it is taking less time and it is not eating a lot of memory. So function basically is a piece of code which accepts inputs, or you can say arguments, and it produces a particular output by just executing. And that is the concept of a function, that I create it separately and I call it whenever I require. So we all know that there are a lot of built-in functions. A lot of functions are there in R, like mean, max, sq, and these are the statistical functions which are already available in R. I have to just call it, and I should know what parameters I have to pass inside it and where to call it. The syntax, I am saying I should know the syntax of the inbuilt functions. But if suppose I want to create my own function, or I can say I want to write user defined function, so there I should know little bit of syntax and understand the concept, that how will I write, where will be the program, where will be the variables, how will I call. So those are the things that I should know. So let's have a look of some built-in functions like sum, max and min, which are already present. You can see the first example. Find sum of numbers 4 to 6. So the problem is that number 4 plus 5 plus 6, that should be my output. So ideally my output should be 15. So what I'm writing, print, and within print itself is a function. Within print, I'm passing the function sum, and within sum, I'm passing the range, which is 4:6. So what I'm doing, I'm passing the sum function inside the print function. And you can see the output is 15 on the right hand side of the PPT. You can see 4 plus 5 plus 6, which becomes 15. Likewise, find max of numbers between 4 to 6. So what is maximum out of 4 to 6? 4, 5, 6. So the maximum is 6. Likewise, find minimum from 4, 5, 6. So the minimum is 4. So basically, we can say that 4 is the minimum, 6 is the maximum, and 15 is the sum. So I could find it very easily because I have used 3 functions which are already provided by R. So these are the functions where I'm doing nothing. I'm just calling the functions, passing the values and watching the results on the screen. Now let's have a look of a function where it is a user defined function. This function is basically a function which I have created. So it is a simple function to calculate the area of circle. Now area of circle is my variable name and I am storing it to the function radius. So what I have done, area of circle is equal to function radius, which means area of circle has been equated to a function where I am passing radius as a variable. Now within the square brackets, within the curly brackets, you can see area variable, which is equal to pi into radius to the power of 2, which means pi r square. Pi into radius into radius. I can also say pi into radius into radius. And then I say return area. So I'm returning the value of area which is captured with the help of the pi r square, and that value is returned. So this is my function definition. Whatever I have written within the curly brackets is my function definition. I've defined my function and I have stored that in area of circle. That is the name of my function. Now, when I'm printing the command, I'm calling the function area of circle. Now think of the function sum, which is the inbuilt. There what I was doing, within the print, I was passing the sum function. Here within the print, I am passing the area of circle function, and within brackets, I am passing the value of radius 2. What I am passing? I am passing 2. So mainly 2 is the value which I have passed. Area of circle is the function which I have defined, and that is why I call it user defined function. This is a user defined function, and this entire function has been passed into the print command. Here it is returning the value of area. And when I am calling the function in the third command, which is the print command, here I am calling the function area of circle with a radius value of 2. So you can say pi into 2 into 2. So pi is 3.14. So 3.14 into 2 into 2, which means 3.14 into 4. So that is how the output is coming, 12.56637. So that is how we are writing a user defined function. So you can see over here, it is so easy to design our own functions and call them and run them and see the output. Let's take one more example and understand the concept of functions. Here, this is a simple R program to demonstrate passing arguments to a function. Basically, when we are passing the arguments, there also we have to understand that how can we pass the arguments. Now, if we see this code very closely, we will see that first we have declared the function which is rectangle, and that function has been defined there only with two variables, length and width, and that function is computing the area and returning the area. Now, in the next line, if we see, there are three cases: case 1, case 2 and case 3. So you can see over here that by default, the values of length is 5 and width is 4, which is assigned at the time of function definition. But if any case I am passing a value, then those values override the default values. So let's understand case 1 now. In the case 1, we have print rectangle 2, 3, which means rectangle 2, 3. Now length becomes 2 and width becomes 3. So which means area becomes 6. So it is if I'm going into the case 1, it is printing 6. If I'm going into the case 2, the width becomes 8 and the length becomes 4. I'm writing width is 8 and length is 4. So you can see over here 8 4s are 32. I'm giving width first and length second, and I'm getting the output 32. And in the case 3, I'm printing by just calling rectangle. I'm only calling rectangle and I am not passing any value, which means it will take 5 and 4, which were given by default at the time of function definition, which you can see in the very first line, and it will do 5 into 4, which is 20. So mainly I am using the function in 3 different ways. In the first way, I am passing the values and automatically 2 will become length and 3 will become width. In the second case, I am explicitly writing the variables that width is 8, length is 4. So if the order is different, that is not an issue. Width will be taken as 8 and length will be taken as 4. And in the third case, I am not passing any values, and in that case, whatever default value is given over there by default, that will be taken and the area will be returned, and that area will be captured by the print command and it will be printed on the screen.